Okay, welcome to my fourth live stream. The topic is pointer-free programming, and unfortunately, I didn't really prepare much. But I didn't really test what I'm trying to write here, so probably there will be lots of issues. But at least I know what I want to say. Okay, so I wrote this blog post about pointer-free programming, and it was mostly about how NIM's destructors and assignment operators should work. And today I want to uh, work on something slightly different, but it's also about pointer-free programming. So when you look into at the big game engines, they usually have something like a particle system or something like that. And the idea is, well, how to put it? Well, let's just change it perhaps. So the problem is that pointers are pretty big on a 64-bit architecture, namely 8 bytes. And usually, if you use an index into an array, you can use fewer bytes. For instance, just unsigned integer 16, so just 2 bytes. If you know that the array, or in this case the sequence, won't be longer than that. So you save memory, and the idea is to make your CPU caches way more effective at processing your data. So and now in this talk here I want to explore how we can make these IDs more convenient to use. So if we compare pointers with IDs, if I have a pointer, I can type pointer dot some field name here. So that's pretty convenient. But as soon as I move into indices, I have these two variables involved, namely the array or sequence and the I. And so where I could use p.fieldName before, I now have to write a at position y.fieldName. So that's a bit messy to do. And so I thought about, well, it's NIM. NIM is really good at making syntactic shortcuts for annoying things like these. And so the first idea was like, let's introduce a template add to turn this array access into a pointer. So we are gonna using the address of operator here, and we are taking the address and probably I should use I here, and okay, so that's and the idea is that we can now write it this way. So kind of like or maybe let's see. So yeah, we want to mutate every element of this E here, and so let's perhaps pick a better name. So this is now a pointer, right? And we have x and y in this object, and so let's see if it works. And I also need to create some test data. I don't know, probably something like this, and It doesn't mutate anything, so maybe let's just name it, I don't know, output. So we want to output the test data, which has a single element, and and we are also after type safety, so we want the, so for if I have an ID of an element, I don't want to be able to mix it, for instance, with an, I don't know, perhaps I have a game and I have units in there, and so there is also a unit ID, and I don't want to be able to pass an element ID where a unit ID is expected, or the other way around. And so this is what the distinct here accomplishes. Okay. So let's compile and run it. And it produces 1, 1, which is correct. Maybe let's try different values. And it still works. Okay, so the add here really just hides the address of, which is unsafe, and well, it's slightly more convenient to use when I write it this way. So there's some highlighting going on here. Nothing important. Okay. Now, the problem is that these pointers here are unsafe, and so well, let's see. So this is a sequence, right? So if I mutate the sequence, then it might be that there is a reallocation happening under the hood, and then the pointer here points into freed memory. So that's a big issue in C++. And first I see if I can actually produce this problem. So now this is gonna mutate our sequence, and we add some object, and to ensure that it actually reallocates, I'm going to use a for loop around this. So for 0 to 100, add these element to the sequence, and so now I take the pointer to the ID element, and then I mutate the sequence, and now this pointer here is not valid anymore. And let's see if it crashes, or yeah, it doesn't crash. That's even worse than crashing. It produces corrupted, it shows corrupted memory. So fortunately there is a way to avoid this, and so if we change the type here, so this is a sequence, but we in this, as long as the pointer to this position exists, this mutation here that actually adds something to the sequence is unsafe, and so I will use an open array here, and so this is still a sequence, and sequences can be passed to open arrays. And now let's see if it still compiles. No, it's type mismatch, because mutate still takes the sequence I should probably type it out. So elements is just an alias for a sequence of elements. So yeah, still wrong. Okay, and now if I try to make it compile, the compiler will tell me open arrays cannot be appended to. So this is very nice. This is exactly what we want here. We want to be able to mutate the sequence but not change its size, and so this var open array here gives us this mutable view on the sequence, but it cannot be reallocated under our hood. So that's very good. But there's shouldn't this work now? Oh no, it's still wrong here. Okay, and yes, it works. But there is another problem, and that is that the pointer here could escape. So, well, probably it's not easy to come up with a realistic example here, but imagine I have some I don't know, some tree, or actually just another object, and it actually contains a pointer to this element, and yeah, I mean it's pretty contrived, but let's see. So I use the P only to get a view into this data, so that I can access P.x instead of having to write E at position ID.x. And now this, since I wrote this P explicitly, I can do dangerous things with this pointer. For instance, I could let it escape into some other data structure here, and I think this, no, what, oh yeah, because it's a distinct type, so I need to convert it to an integer first, because it's a distinct index. Okay, so the this add here is a bit too simplistic, because now I still have these pointers, and also if you scale it a bit up, so for instance I have IDA here, IDB, and I need to come up with names for these. For instance, I don't know, A is IDA, and B is E at IDB, and now I have these pointers here that give me this convenient access, but these are dangerous because I could pass them on to something, and I don't want to allow this. So my idea is to so okay, a question tree form is asking, is E at ID the same as EID? Okay, people are already helping him. So the idea is to have a macro that makes this more convenient to use and even safer to use. And I don't really have a good name for this, so I will just call my macro pointers. And yeah. And the idea is that with this pointers, within this pointers macro, I can actually use this IDA as if it would point into this E. So for example, the idea is I don't need these temporary pointers. I can simply write IDA.x, and the compiler transforms it into something that actually works, because this is just a number, but I'm treating it as a pointer in here. And I don't know, perhaps IDB of x, IDB.y here. So this would actually, in some sense, fake the pointers for me. And since these P's and Q's are not visible in my code anymore, I cannot pass them to some other proc that takes them. So it's safe. And also I can even decide whether I actually want to transform it into this address thing here, or whether this is too dangerous because this can grow, and whether it should not introduce a pointer to here, but rewrite this this expression into this expression for me. And maybe we can detect this at compile time. So for example, I could imagine if I'm using open array, then this macro introduces real pointers for me because they should be slightly faster. And if I have a sequence here, then this macro should still use the indexed access because this is safe against relocations for the sequence. Pretty nice idea, right? So, and now it will probably get messy because and maybe I will patch the compiler for this. So this macro here needs to take an untyped AST, which means that no symbol lookups have been performed and no type checking, because what we are going to see in this body here is actually not type. I mean, the types make no sense, right? You cannot access IDA.x because IDA is just a number. So this macro needs to rewrite these before we can do any type checking, and so this means it takes an untyped node. So since we don't really have type information, I think I will go with some slight hack here, and look at this type just by syntactically. So if we have a type ending in this ID suffix, we're gonna treat these parameters as pointers within the body, and we also need to wait to see what they are referring to, and we will probably just use the first parameter here. So the first parameter will be indexed by any parameter having a type that ends in ID. Okay. So let me write down what this macro needs to do. So first step is collect the parameter names we want to transform into pointers. Second step, process the body of the proc, replace, and now here it comes, so replace param.field with and now first param at position param dot field, or by this or by I don't know, derived pointer of first parameter at position param dot field, and for now we gonna do this only, and then we will expand the logic. Okay. So I fixed my name suggest so that it doesn't work anymore. But this is already looking good. So first we want to say this PTR's macro works on routines, so we expect a routine here. And if it's not a routine, the macro will hopefully produce a nice compile time error message, and the programmer can then fix his code. So there's a question in the chat. Let's see. The PTR's macro should really accept the index or name of the parameter to reference. Yeah, that's probably a good idea. But maybe we will later improve it. Let's keep it as simple as possible first and then expand it into something useful. So let's see, there is, I think, an accessor that lets me iterate over the parameters of some proc. Yeah, here it is. And if we look at the code, it actually enforces this expect routine for us already, so we can remove this again. So and we need to collect it, so probably I should use a hash table to be able to look up the parameter names that interest us. Yeah, I don't know. Actually, it's just a set, right? I think it's new hash set. I'm not sure what people in the channel are talking about. Yeah, don't distract me. Okay. And I think the parameters are actually quite messy to deal with in them. So I think I need to start from 1 here to the length. And then we have this strange thing called NNK ident_def. So the idea is you have something like 1, 2 type here equals default, and so this kind of list of things is called an ident_def. Maybe we should rename it, but I don't know any better name. So, and the last, so this and now I don't want, so let's see. So until length -3 are actually these 1, 2 guys here, and then at length -2 that's the type, and let's see. So if this set -2 is the type, and we want to compare the suffix against ID, so probably I'm not so sure. Probably the condition looks like this. I need to import string details. So if it ends in ID, these names that I'm iterating over here are interesting. And I need to convert the names into strings, and I hope wrapper does that for me here. We'll see. Yeah, perhaps let's run it already and see if it works. And we want to return this n unmodified for now. New hash set. What is its name? No, that's not sets. Oh, I think it's hash sets. No, what's the name of this module again? Oh no, it sets nim, but it's in pure collections. Okay. And init set, to set. Okay, that's new. Let's use init set. So I misremember. It's not a hash set. It's just a set. No. Oh, it's not ident_def. Is it ident_defs then? Yes. Okay. Ah. Okay, that's cool. So this part of the logic already works, and it says IDA and IDB are interesting names. Okay, nice. So, and now we want to recurse over the body. So usually this is then done with a helper, and I never really know how to name anything. So I'm naming it helper. Probably it should be, I don't know, process body or something. But I'll probably use H here and then rename it into something longer after I've written the code. And by the way, I still see this all the time, and it's really not required anymore. The compiler now knows that nim nodes are special and only compile time things, and so it infers this compile time now, so there's no need to write it. And also we need to pass this interesting here to us. So now I'm still confused. So I think it's hash set of string. And so what are the interesting case that I want to detect? It's a dot access here. So if we got this dot expression here and wrapper of this, so this zero, so the object in this object.field notation is interesting, then we want to rewrite it, right? We want to rewrite it into first parameter field. So this is a bracket expression. We need the first parameter. And we use the n at position 0. Okay, here's an interesting question, and that is why is it a PTR's macro over the whole function and not something like a safe pointer of B? Because we then I don't, maybe it's possible, but I think right now it's not possible, because then I introduced this A as a PTR, and PTRs are unsafe in NIM, and the compiler will happily use us this A in contexts that are dangerous, like letting the pointer escape into something else. Okay, I hope this answers the question. So, and this is actually wrong, because this is a position y, but we still want the dot field access here. So we wrap this into a new tree, and that's the dot expression, and we use the field name here. So actually this is a node with 2 children, and we now use both children, and so this looks pretty good because we do not lose any information here. Probably, okay, so let's do it this way. So, and if we don't have such an interesting node, we simply want to recurse, and I don't really, I mean, this is the standard recursion for macros. So we copy the node and then we append the transformed node to the copy. And probably we should have something in NIM that is just recurse. And I don't know, it works with magic, so it writes this for us out. But yeah, we don't have recurse yet. Another question, why copy instead of just returning n in the else block? Yeah, well, you need to return, I mean, you cannot leave the n as it is, because you need to look inside the n. Maybe in the within the n there is still some dot expression that we want to rewrite here. Okay. Same problem here. So we want to copy the node n, and then we want to set the body to the transformed body. We computed the interesting, and the first parameter is I probably can start at position 2 here, but later we want to be able to make this more flexible, so I'm leaving the 1 here. So the first parameter that we are looking for is actually at params position 1. So in parameters is a bit, well, it's messy to deal with, because at position 0 there's actually the return type, which would be this here, which in this case we don't have it, but it's still there. And so we use the 1 here and not the 0. And this is then this ident_defs weirdly, and so we need to access it at position 1 here. And but yeah, that's the first implementation. Let's see if it compiles and works. Ha! Index out of bounds. And 9. Why is it index? So yes, this is the body accessor. Oh yeah, I know. We only copy the node, but we need to copy. So this copies only the single node n, but we want to copy the tree instead. And yeah, that looks pretty nice already. So the one thing that we forgot is we cast to int here. So, and I cannot just write .int here because that's the wrong level. Usually I cheat here, and so these type conversions are usually, well, you do not have to use the dot notation here. So then the type conversion is actually just the same syntax as a call, and so I can get this type conversion to int via this new call here. Yeah, works. Okay, that's pretty cool. Now let's see how we want to deal with this. Yeah, maybe before I go on, I will tell you more tricks. So usually when I write these DSLs like these, I introduce a debugging tool, and this is usually something like debug and the macro name. So, and then these days I usually add also DSL. So if debug pointers DSL is defined, we want to show the result of this transformation and send it output. So let's see if it works. Yes. So the macro produced this piece of code for us, and that's actually, yeah. Okay, now let's make it more complex. So this the derived pointer. Maybe let's do it like this. So this is PTR's on a sequence, and now I want to have this same thing on an open array. Okay, more questions. Interesting. So shouldn't you actually use bind sum int here? Yes, that is correct. So if I do not use the bind sum, then the int is looked up in the current scope, and it would fail me if I do something weird in here, like I redefine int to mean string. But with this bind sum, it's actually looked up within the scope here, and so there is no weird int in there. And so it binds to the system.int, which is the integer type. Okay. So let's see. So on sequences, since they can grow and shrink, I want this transformation here. And on open arrays, I can introduce pointers in the hope that they are more efficient, though probably not. When I think about how modern compiler optimizers work, it's really not a problem to let the C compiler introduce these pointers at this point here. But it's an interesting exercise anyway. Okay. So we want a different transformation here. Yeah, so let's copy and adapt it. And this strange idea that my code should be intended at this level is driving me crazy. If you know how to change Visual Studio Code to not do this, please tell me. And I really don't like naming things. So this is h2, and now we still want the dot expression, but what we want is just the introduced pointer dot field, and the produced pointer is not really known, but I will introduce a naming convention. So the derived pointer from the index will be called like the index, but with the suffix derived pointer. And I need to introduce these derived pointers. So I can do it here. So I need a statement list. Let's call it init section. So there is an init section that we need to introduce, and in this init section, for every interesting parameter, we derive things. So oh yeah, and this first parameter is not used here, so I can remove it. So the array, so what do we need to do here? We add to the init section some assignment statement, and there is a new let statement, yes. And I think it already does the right thing, so and usually you should do something like to avoid typos, so derive pointer name so there's no way I could possibly write this string literal wrong because it's only used in one place. So, and this needs to be an identifier, so and the value is now let's have a look. Replace with, no, that's actually not in here. What we need to do is to add statements like param id derive pointer is the address of our first parameter at position param id dot int, and there are multiple ways to do this. I still like the template, the helper template. Okay, another question. Why use wrapper versus the dollar? The dollar is I should probably fix that too. Maybe I can do it afterwards. So the dollar for nim nodes is something weird, and that is it only works for some types, so for some node kinds that are listed in here, and the wrapper works for any node kind, and so using wrapper instead of the dollar is more is more safer to use. But I think I could change the implementation to this. And probably wrapper is also misnamed because wrapper without the macro outside of the macro system uses this representation of an object like quoting strings, etc., showing some weird pointer addresses. And so, and wrapper for macros is completely different, and so we should probably change that. Okay. Yeah, no other questions for now. So I want to produce this address thing here, and the template is just address of. Actually, I could use the at here, but I want to remove it, so let me name it address of, and then we write get AST address of. The array is what we want, and IT at position J is still the parameter name. So, and now we need to ensure that this init section ends up in our body. Yeah, I'm not sure. I cannot write it this way because the nodes don't support this concatenation operator, but it doesn't matter much. We can do it this way instead. And so this is pointers on open array. And let's see if it compiles now. New tree is oh yeah, it's a string here, and we need to convert it into an identifier. Yeah, works. Okay, that's pretty cool. And now the difficult part, making this macro decide on its own whether to use the pointer variant or the array variant. And so the problem is we can, so there are actually two ways to do this. So one is we do some hacky introspection here and see if it's an open array. The alternative is to make this macro generate. Well, maybe I will show it here. No. Yeah. And so maybe we can also make the macro not distinguish between these two cases, and instead producing a when statement. So we could make the macro produce this when in the body, and let the compiler after the macro expansion decide which version to take for these. So this would be the result then. But I don't know. It's this will be more code, right? Essentially, we need to duplicate this whole proc body, and I'm not so sure whether I really like that, because then what is a single line in here becomes yeah, well, 6 lines here, and I'm not so sure it's worth it. Also, I mean, in theory, you can write in theory you can alias this type, and then if you just look syntactically at this thing, you would fail, but nobody really writes this. So I would probably take the guess the parameters type route here, since we already are guessing what to do anyway with this ID suffix here. So yeah, let's do that instead. And then the resulting code is not as messy to look at, because eventually you also need to debug your programs. Okay, so we have both implementations, and I think yes. So all we need to do is to look at this array here in order to decide so if is open array, then we want this pointers on open array, and else we want this pointers on sequence, and I want this debugging helper only here, and I cannot really, so this would be a macro invocation of this thing, which is not what I want. I want to call this as a compile time proc, and so that's what I'm going to change here. And that should be all I need to change really to make this a compile time proc instead of a macro. Same here. And oh yeah, what's left to do now is to write this open array helper. So as we can see here, it could be prefixed by a var type. I think that's then, oh yeah, maybe let's, so it's an n, so if it's, I think it's var ty, Then we want this, and afterwards it could be a bracket expression. Oh, comment. Is open array should return bool. Yes, that's completely correct. Yes. And there's actually a helper for comparing ident nodes, when it's, I think, no, oh yeah, because sometimes we want to adhere to NIM's rules, ignoring the style as it's written. Treeform is asking, do people use OpenArray? I always use a sec, should I use it more? Well, as I said, OpenArray is more restrictive because OpenArray doesn't allow you to grow or shrink the sequence, and that's exactly what we want here, since we are gonna produce pointers into this array. But that aside, oh yeah, treeform, that's also a good answer. So yes, you should use OpenArray more, because then people can also call your code with arrays as well. Okay. So we want to compare this. And let's see if it works. No! Oh, kaboom! So what's the pointers on a sequence? So we want a lambda, but they got the symbol. Which one? Which symbol did you get? Ignoring the fact that it should call the other. N. Oh yeah, that makes sense, because it's still a macro. Okay, but I've already seen that this doesn't really work here. The question is why. I think that, I don't know, is this dump echo tree wrapper is also nice to look at it. Yes, that's now pointers. Is OpenArray is the E? Oh yeah, I see. Because I'm looking at this here and I want to look at the type instead, which I've explained is at position -2. Yes. Okay. Works. Yeah, okay. I mean, any other things that people want me to do? Because that's what I wanted to show tonight, really. How to use, or how to make indices as convenient to use as pointers without having their disadvantages, like memory safety. So again, as I didn't write the pointers that are introduced here for me, I cannot get them wrong. And you can also drew some conclusions or perhaps make some connections to Rust again. So in Rust you would have borrowed pointers that would point to some parameter and wouldn't be allowed to escape the scope, and that's actually what we are doing here. So maybe we can use it, we can name it even like borrow pointers for us, and to get pretty much the same safety without making the language ever more complex. And again, another advantage is that these IDs can be small. So these now take 2 bytes instead of 8 bytes. So you can pack many more of these into a cache line and have the CPU run faster over the data structure. And also, of course, IDs have the advantage that you can actually send them to the disk, right? They are easier to serialize. So yeah, there's one more question. What about parameters where there is no type info at position -2? Well, then we crash. We could, I don't know, you could write something like, first of all, this should be this identdefs thingy, and this is actually guaranteed to be of length 3. So but it could be empty, right? If I ever write something like default value here, then the type would be empty, but then it wouldn't be an open array, and the compiler would, the macro would produce E at position IDA. I mean, let's perhaps test it. Yeah, so it says instantiation from here. Actually, the line information could be better. We should probably, when we construct the tree, pass the line information properly around. But I don't want to do this tonight. But yeah, I mean, it errors. It's close to the real error position, and we have this nice debug output of the whole macro transformation that we are getting via this debug pointers DSL. Okay, so that's it for today. I hope you enjoyed it, and see you the next time.